Today our topic is properties of tangent. So our learning target, how can I use properties of a tangent to a circle? So vocabulary here. Circle is a set of all points in a plane that are equidistant. From the center of the circle. So equidistant means same distance. The center is the middle of the circle. So a circle with center P is called circle P. So we name the circle by its center. Radius is the segments whose points are the center and a point on the circle. A chord is a segment whose endpoints are both on a circle. So both the endpoints lie on the circle. Diameter is a chord. So it's a chord, but it's a special type of chord. It contains the center of the circle. Secant is a line that intersects a circle in 2 points. So it's different from a chord, because a chord is a segment. A secant is a line. Tangent is a line that intersects the circle in exactly 1 point. That point that it intersects the circle, that intersection, is called the point of tangency. So now we have these circles down here that give us a nice image of these points. We want to label the pieces of the circle. So right now I'd like you to pause the video, and based off of the definitions, I'd like you to try and label each piece of the circle. And then once you are ready, you can play the video and see if you're right. All right, so if we start with the very first vocabulary word, center, this point right here, point O, would be the center of the circle. So we would call this circle O. Next piece is the radius, and the radius is 1 point with a center and 1 point on the circle. So this one is our radius. A chord has its endpoints touching the sides of the circle, so PQ would be a chord. Then our special chord would be the diameter, and that would be endpoints on the sides of the circle and then goes through the center of the circle. So this AB would be our diameter. Going over to the second circle, we have the line AD would be a secant to the circle as it goes through 2 points of the circle. And then BC would be tangent to the circle, and right here, this point where they cross would be the point of tangency. All right, example 1, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So this is another way you'll see a circle labeled, with this drawing of a circle, and then the center after the image. So AC, if we look at AC, center to the side of the circle, that's a radius. DE, right here, it's a line that only touches the circle at 1 point, so that is a tangent. AB, right here in red, goes through the center of the circle but touches both sides of the circle, so that is the diameter. And then line AE, we look at that right here, goes through 2 points of the circle, so that would be a secant. Theorem 10.1. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So if we look at our drawing, right here, QP, that's the radius of the circle, which is perpendicular to this line M. So since it's perpendicular, that line is tangent to the circle. So in the diagram, PT is a radius of circle P. So right here, that's the radius. Is ST tangent to circle P? So we want to know, is this line tangent to the circle? So we want to know, is this a right angle? Well, if we look, we have a nice pretty right triangle. So we are back to Pythagorean theorem. We want to know, is that a right triangle? So we want to use the converse of the Pythagorean theorem, which states if c squared equals a squared plus b squared, then it is a right triangle. So let's look. Across from the right angle, 37 would be our hypotenuse, which would be our c. Then we have our two legs, 12 and 35. So c squared, we would put 37 squared equals 12 squared plus 35 squared. Let's see if that holds true. 37 squared is 1,369, which equals 12 squared, which is 144, plus 35 squared, which is 1225. 144 plus 1225 is 1,369, which equals 1,369. So we can say this is a right triangle, which means that is a right angle, which means segment ST is tangent to circle P. Next example, in the diagram, B is a point of tangency. So right here we know this point is tangent to the circle, which means this angle right here with the radius and the point of tangency is a right angle. Find the radius R of circle C. Again, we're going to be using the Pythagorean theorem, but we're just going to be using regular Pythagorean theorem this time. Right here, 50 feet plus R is our hypotenuse. So we can say 50 plus R, we're squaring that quantity, equals our legs squared. So 80 squared plus our other leg squared, R squared. 50 plus R squared, that's squaring a binomial. So this is kind of review from the end of last year. We use the box method. So we have 50 plus R times 50 plus R. We just multiply each piece together. 50 times 50 is 2,500. 50 times R is 50R. 50 times R is 50R. And then R times R is R squared. Then we just want to make sure we're adding up R-like terms. So 2,500 is all by itself. There's no other just number, so we can put 2,500. Then we have 50R, which is alike to 50R. See that in that diagonal. So 50R plus 50R would be 100R. And then R squared is all by itself, so plus R squared. Equals 80 squared, which we can evaluate. So let's evaluate 80 squared, which is 6,400 plus R squared. Now we want to solve for R. So we want to get our like terms together. We can move r squared to join the other r squared, minus r squared on both sides. Those would both cancel out. And then we can also move 2,500 to go join 6,400. 2,500 minus 2,500 is 0, leaving us with 100r. 6,400 minus 2,500 is 3,900. Get r by itself by dividing both sides by 100, and we get r equals 39. So our radius would be 39, and we would want to include our unit feet, 39 feet. Last example, Theorem 10.2. Tangent segments come from a common external point are congruent. So if you have two tangents to a circle that come from a common external point, so here in our example, our common external point would be S. And then we have two tangents, RS and TS. So since they come from a common external point, we can say that they are congruent. So in our example, RS is tangent to circle C at point S, and RT is tangent to circle C at point T. They come from this common external point of R, which means we know that the red line and the green line are congruent. So to solve for the value of x, we set 28 equal to 3x plus 4 and solve for x. Minus 4 on both sides, 24 equals 3x, divide by 3 on both sides, and we say x equals 8. That's all the notes that I have for you today. Thank you for watching this video, and please remember to take your 10.1 video notes quiz to practice what you learned in this video.